Hello, good afternoon all. This is your 20th lecture of your C programming lecture series and currently we are under module 3. Today we'll discuss more in array. Already we have one class regarding array discussion. What is an array, how to declare an array, how to initialize an array, how to take the input for an array during runtime, how to display an array, and every details we discussed about array. Now we'll see how to allocate memory for an array. Then we'll solve some problems regarding an array, that means manipulating an array. Today we'll have more discussion on examples in an array. Okay. So let us start with our discussion. So anyone present? Allocating memory for an array. Okay. So till now we discussed whatever we discussed in the previous class, that is all about your one-dimensional array. Okay. So in one-dimensional array, only you have the elements stored in either a row or in a column. That means when we represent the array logically, we can represent like this. This is a row representation. Okay. So whenever I am saying this representation, this is your column representation. Okay. So let us take an example of an one-dimensional array. This is an integer array. The array name is A and the element it carries 5. That means the size of an array is 5. Okay. So this is one dimension because either we store the 5 elements in a row or in a column. Okay. Then you must be thinking that how the memory is going to allocate for an array. As we know that array elements are stored in consecutive location. So if I'm going to store these elements in an array, so one, two, three, four, 5. So I have to initialize the array. Initialization can be two ways. Like simply I can write A of 5 equals to 10, 12, 14, 16, 18. I can write like this. That means while writing the code, I am declaring, then I am initializing the array. The elements will be stored here like this: 10, 12, 14, 16, 18. If it is a 32 or 64 bit compiler, then each will carry 4 byte of address. This is 4 byte. This is 4 byte of memory, 4 byte. This is 4 byte. This is 4 byte. Again, this is 4 byte. So how we will do addressing part over here? Okay. So let us coming to addressing. The starting address, this is the address. The starting address where the array is stored, this is called as base address. Okay. The starting address where the array is stored, this is called as base address of an array. So the array name is A. Okay. So the array name itself stores the base address. That means here A is the location. A is the name of the location which is holding the base address. If the base address is, let it be 1000, so this A will be holding 1000 and A pointing to this location. Okay. So as this is starting from 1000, so 1000, 1001, 2, 3. Okay. So this will end with, or the range will vary from 1000 to 1003. So for these 12, it will start from 1004. So it will go up to 1007. Okay. This will start from 1008. This will go up to 1011. Then for 16, this will start from 1012. This will go up to 1015. This will start from 1016 and it will go up to 1019. Okay. So the starting address is equal to 1000. This is also called as starting address or base address of an array. Okay. So this is the base address of an array. Okay. Suppose I want to, every element has some starting address. The first element is 1000, second element is 1004, third element is 1008, fourth element is 1012, fifth element is 1016. It has indexes as well. Array indexes starts from 0. This is 0th element, this is first element, this is second element, this is third element, this is fourth element. That means here A of 0 is equals to 10, A of 1 is equals to 12, A of 2 is equals to 14, A of 3 is equals to 16, A of 4 is equals to 18. Okay, I think it is clear to all of you. Next, the base address of the starting address of an array is provided by A, or you can say A of 0. So the address for this A of 0 is, starting address is 1000. Here the starting address is 1004. Here the starting address is 1008. Here the starting address is 1012. Here the starting address is 1016. Okay. Suppose I want to randomly calculate. Okay. Suppose my array, this is my array given, the base address is given, then I need to calculate directly A of 4. My base address is given, is 1000. Without doing this sequentially, manually, I need to directly calculate any location address. So that will be calculated by base address plus. Okay, base address plus, what is the index of an, what is this index? I want to calculate A of index, this desired location. So desired index, if I'll say that this is 4, desired index is here 4 into size of each element. Size of each element. Okay. So this is, rather than 4, if I'll write n over here, what is the, if I'll write, what is the storage location of A of n. So here this will be multiplied by, n. A of n means given index, n into this n into size of each element. That means suppose I want to calculate the storage location for A of 4. So the base address is 1000 plus 4 into, है ना, 4 into size of each element is 4 byte. Okay, so I'm just not considering this byte. This is the unit, so this is 4. So 1000 plus 4 into 4 is 16. So the address of A of 4 is 1016. Okay. Similarly, let us take another example. Okay. I have an array of size 10 and the base address given is 1020. Calculate A of 8. Considering the size of each element is equals to 2 byte. Okay, so 16-bit compiler, each integer array. Okay, this is an integer array. That is A of 10 with 10 elements. The size of each element in a 16-bit compiler is 2 byte. Okay, so how to calculate the storage location of A of 8. Okay, so how you will be calculating? The solution is, so here it is given A of 8. Okay, so the storage of A of 8, is equals to base address. The base address is given is 1020 plus what is the size of index? What is this index? The index value is 8 multiplied by what is the size of each element in an array? This is 2 bytes. So 1020 plus 8 into 216, that is 1036. Okay. So whether what I have calculated, this is same as the manual calculation or not, let me draw it. This is an array of 10 elements. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, so let us this is 0, this is 1, 2, 3, 4, 5, 6, 7, 8, this is a 9. So this is an array of 10 elements. The array name is A. The base address is 1020. Okay, so as it is 2 byte, 1020 and 1021, 1020 and 1021. This is the first index. Okay, so 1022 is here, 1022 and 1023. This is the address of this. 1024 and 1025. This is the address of this, starting with 10 and go up to 1025. Okay, 1024 and go up to 1025. This fourth element, that is A of 3, this is 1026, 1027. This is 1028, 1029. This is 1030, 1031. This is 1032, 1033. This is 1034, 1035. This is starting address is 1036. So here you can see A of 8, this is the starting address is 1036. Now it is verified. Now I think it is clear to all of you how to calculate the starting address of a particular location if your base address is given and size of each element is given. Is it clear? If yes, then drop a message in the comment section if anyone present over here. Okay, not a issue. Now we'll discuss some examples on operation in an array. Okay. So I can perform search an element in an array. Search an element in an array. Okay. I can perform sum of elements in an array. Sum of elements of an array. I can print even element in an array. I can find smallest element in an array. Okay, similarly you can insert an element to an array, delete an element from an array. So several operations you can perform on an array. Okay, so let us discuss one by one. I want to search an element in an array. The first example is, the first operation is searching an element in an array. So this is one. Search an element in an array. So for searching an element in an array, I need to first take an array. That means I need to initialize an array. Okay. So searching an element means it can be integer array, it can be float array, it can be character array. So let us take, I am taking an array of float, array of data type float. Okay. So how do I approach this program? So this is my, let us say, this is my array whose name is B. Its size is, let it be 1, 2, 3, 4, 5, 6. So this is the maximum element I can enter into this array is 6. The name of an array is B. This is a float array. That means the data type of array is float. So that means the elements I need to enter into an array will be of float type. So as you know that array contains all elements of same data type. So all the elements will be of type float. Okay. So this is your B of 0. This is your B of 1. This is your B of 2. Okay. So to access this particular element, I will have to write B of 0. Okay. So let us only write the index itself, not B of this like this. So just write, this is my 0th index, this is first, this is second, this is third, this is fourth, this is fifth. Okay. So I need to initialize the elements of an array. There are two ways. While declaring, I can initialize, or I can take the input from the keyboard by a scanf statement. So I need to enter the input through the scanf. Okay. So during runtime, I entered 10.1, 12.6, 13.8, 14.2, 15.0, 16.1. Let us say these are the elements that are present in an array. I have entered through the keyboard. Suppose I want to search a particular element 18.0. Okay. So then how to check whether this element is present or not? So I'll sequentially go for each and individual elements one by one. So this is my element I want to search. So element is a variable whose value is equals to 18.0. So element must be of floating point type, because whenever I am searching an element into a floating point array, the element must be a floating point type. So I need to take another variable that is float type element that is equal to 18.0. So how I will be searching? Okay, so I need to take the for loop, because to check individual elements one by one, I need to run a loop, because the repeated steps I am doing, what I am doing, I am checking this element with A of B of 0, element with B of 1, element with B of 2, element with B of 3, element with B of 4, element with B of 5. So I am checking one by one all the elements. So I have to take a loop. Okay. So to write this program, so let us start with has include. I need to include the header file. Then start with main function. Then declare an array. Float B of 6. I told you while declaring an array, you need to mention the maximum element that can be inputted to an array. If you are leaving this size, or you can say maximum size, then you need to initialize over here. Okay. So if you are simply declaring, then you need to mention the size. So this is declaration. Okay. Then I am declaring another variable float element whose value is given is, you can take this input while through scanf, or else you can simply take the fixed value. Okay, so I need to take both the values for element and array through scanf statement. So first I have to give a printf statement. Printf, enter the element you want to search. Enter the element you want to search. Okay. Then scanf percentile f ampersand ELE. That means you will take the value for element through a keyboard. Next, I have to give another printf statement. Printf, enter the elements of an array. Enter the elements of an array. Okay. Then for entering elements of an array, I need a for loop. So for I equals to 0, as the size of array is 6, so I less than 6. Okay, because when it is starting from 0, it will go to 5. So I less than 6, I plus plus. Okay. So enter the elements of an array of size 6. That means आपको पता चलेगा कि आपको 6 elements लेना है. Then I need to write the scanf statement. Scanf percentile f, because this is a floating point array, ampersand b of I. So you will take input one by one, and this will loop up to this will run. The iteration will start from 0 and with end over here. Okay. So already you have entered the input for 6 elements. Then I need to search the element in an array. So for searching the element in an array, again I have to take another loop, that is for I equals to 0, I less than 6, I plus plus. You have to traverse the array. Okay. So that you can check whether the element is present or not. Here I have to give the condition if. Okay. If element, for element I have taken the variable as ELE. If this ELE is equals to B of I, that means it may be equal to B of 0, it may be equal to B of 1, it may be equal to B of 2. जहां पे भी मेरे को एलिमेंट मिल जाएगा देन वो क्या करेगा, बाहर आ जाएगा. क्योंकि सपोज मान लो मेरे को सेकेंड एलिमेंट पे मेरे को मिल गया, राइट. सो दिस इज माई अरे. नाउ I am searching, let it be, I am searching 18.0. So 18.0, this will not find it anywhere in the array. So definitely it will come out of the loop. So it will traverse the entire array, and if it doesn't find, then it will come out of the loop. If it finds an element in an array, okay, if it finds an element in an array, then what it will, suppose let us take, if I am searching for 12.6, okay. So if it is 12, if it is searching for 12.6, then it will definitely find this element in the second index. If I am finding this element here, then why should we go for remaining elements? Why should we search remaining element? Unnecessarily wastage of time. Okay. So in that case, I need to give a break statement over here. That means if this condition satisfies, that means I found an element. Okay. So here I can take another variable, that is flag. Okay. So here I can take another variable, that is integer flag. Flag is a variable. Okay. So that is equals to 0. Okay. So I have set a variable that is equal to 0. If I am finding an element, if I am finding an element inside the array, then set flag equals to 1. That means if the status of the flag has been changed, this is just a variable, I am changing the status of the variable from 0 to 1 when I find an element. If I find an element, then I need to break the loop. That means I should come out of the loop and print the element equals to percentile D is found at कौन से लोकेशन में हमें मिला, ith लोकेशन में मिला. दैट मीन्स फाउंड एट, दिस इज मान लो सेकेंड लोकेशन पे मिला तो i इक्वल टू 1, सो i प्लस 1, फाउंड एट i प्लस 1. ओके. सो फाउंड एट i प्लस 1, सॉरी i प्लस 1 इक्वल्स टू परसेंटाइल डी. दैट मीन्स इस लोकेशन पे आपको मिला. सो एलिमेंट के लिए आपको प्रिंट करोगे एलिमेंट, और लोकेशन के लिए आप प्रिंट करोगे i प्लस 1. ओके. सो दिस इज योर एंड ऑफ योर मेन प्रोग्राम. ओके. So this is how you are going to search an element, and if the element is found, then flag becomes 1, then you will print the element and location of that element. I think it is clear. Those who are present say yes. Then we will proceed to next program. So let me do the coding part. Let me show you the coding part. Has include stdio.h. okay. So void main, I am taking the float as an array, float that is p of 6. Then float element which I want to find out. Then integer flag to check whether this element I found or not. Then enter the element you want to search. Scanf percentile F ampersand element. So here you enter the element, then write another printf statement. Printf enter the array elements of size 6. That means अभी आपको 6 एलिमेंट एंटर करना है. Okay, then you have to take the for loop for I equals to 0, I less than 6, I plus plus. Okay, you have to declare I also. I forgot. Okay, so I, because I is used for indexing. So scanf percentile F, here you are entering the elements one by one, ampersand B of I. So now you need to search the element into an array. Then I am just copying this code, and rather than scanf, what I am doing, writing the condition if element equals to checking double equals to, if the elements is equals to B of I, if it match with any of the index, then what it will do, it will set flag equals to 1. That means the element is found. Then it will set a break statement. That means it will come out of the for loop. After coming out of the for loop, it will printf element found is percentile D at location percentile D. So जो एलिमेंट फाउंड हुआ उसके लिए हम लिखेंगे yearly, और जो लोकेशन पे फाउंड हुआ दैट इज I+1. ओके, सो नाउ save this program. This is array example 1. Okay, now I need to compile. Yes. Oh, is there any error? Okay, it has include INCLU typing mistake. Then compile and run. Yes, this is the element you want to search is 12.3. Okay, the array elements of size 6, 12, 23.4, 3, 22.1, 12.3, 11.4, 33.6, 1, 2, 3, 4, 5, 6. Now you entered. The element found is this, and at location is 1. Element found is this 12.3. Okay, let me check where is the error. Element ELE, percentile F ELE. Okay, I need to give the format specifier as percentile F. That's why it is giving me error. This is this location is percentile D, but the element is percentile F. That's why it is giving me garbage value. Compile and run. The element you want to search, this is 12.1. Okay. The size 6 elements I want to enter, 12.1, 22.2, 33.3, 44.4, 55.5, 66.6, 6 element. So the element found is 12.1 at location. This is the first location of an array. So this is found in location 1. Though the index starts from 0, but this is the first, index 0 is the first location. That's why I have mentioned I plus 1. Okay. Because index is starting with 0, 0 plus 1 means this is the first location where I found my desired element. Suppose let us run the program again. That means I want to find 12.2, but the element is not anywhere. 12.3, 23.3, 33.4, 44.3, 45.5. 55.6. That means I want to search 12.2, but these are the elements 12.3, 23.3, 33.4. So it is not found anywhere. So if it is not found anywhere, so it is the element found is 12.2 at location 1. How come it is showing location 1? If this is the case, acha, I need to give the curly braces, okay, because there are two statements under if, so I need to give the curly braces, okay. So now else part, if the element is not found, it should print the element is not found, else printf element is not found. Okay. Now you can see. That means here there are two statements. That means if element is found, it set flag equal to 1 and it will break. So if there are two statements, so you need to give curly braces. Okay. So now run the program. So this is for loop. Okay. Then, okay, I need to give the semicolon. Execute, compile. It is successfully compiled. I want to search 12.0. Okay, but the array is 12.3, 33.2, 34.4, 45.0, 55.2, 44.3. Okay, so the array element is not found, array element is not found. Okay, so this is as I have written inside the else. Okay, so that's why it is printing element is not found multiple times. Okay, so here I can do one thing. So here I'm not writing else over here. Okay, so outside the function, if the flag equals to here I have to check if flag equals to 1, that means element is found, else printf element is not found. Okay, so अगर मेरा फ्लैग 1 हुआ है चेंज, then element found, otherwise not found. Then I need to compile and run. Okay, I want to search 10.2. So I have entered element 11.2, 22.2, 33.2, 44.2, 55.3, 66.4. So as you can see, 1, 2, 3, 4, 6 elements are there and 10.2 is not there. So it is giving me element is not found. Okay, that means Here earlier we were writing the else statement in the loop itself. That's why it was multiple times giving the element is not found. But what I did, if I found the elements, I'll set flag equals to 1 and come out of the loop. Here I'm checking if flag equal to 1, then definitely my element is found in the loop. Otherwise, that means otherwise means if the flag equals to 0, then element is not found. I think all of you are clear with this code and this programming. Okay, so next program is sum of elements of an array. Okay, so I need to print the sum of elements of an array. Suppose this is my example 2. Okay, print sum of elements of an array. So I need to take the elements first. Okay, so for that, if this is my array of integer, so integer a of 5 elements array. So 1 2 3 4 5, this is 10, this is 20, this is 30, this is 40, this is 50. So how I'll find the elements of an array? First, when I'll be traversing element, first element I'll be getting 10. So I must add this with someone. Okay. So when I'll traverse second element, when I'll go for second time in the for loop, then I'll get second element. As we know that plus is a binary operation, so I definitely need two operands. So here for addition operation, I can write sum equals to sum plus a of I. When I will be 0, a of 0 is 10, this will be added with sum. Sum should be initialized to 0. So that 0 will be added with 10 and it will be stored in sum, that is 10. Okay. So when ai becomes 1, this is 0th index, 1 index, 2 index, 3 index, 4 index. When I becomes 1, a of 1 will be added with sum. So a of 1 is equals to sum plus a of 1. This is your a of 0. Sum plus a of 1. What is the value of sum? Previously we calculated. Previous value of sum is 10. Plus a of 1 is 20. So this will be stored in sum, that is 30. Okay. Similarly, next when I becomes 2, this becomes 30. 30 plus 30 will be added and result will be stored in sum. In this way, after the loop completes, the sum will contain the entire addition of the elements of an array. Okay. So let us write down the code for this. I need to declare an array of 5. Here I am initializing the array elements 10, 20, 30, 40 and 50. 5 elements. Again I need to declare a variable sum that must be initialized to 0. Okay. So already I have taken the array elements, so I don't have to take the scanf statement. Simply what I'll do, I'll take a for loop for I equals to 0, I less than 5, I plus plus. Then what I am doing, sum equals to sum plus a of I. Okay. So after the end of the loop, so sum will contain the addition of all the elements of an array. Then after that, what I am doing, printing of the elements of array. Print the sum of elements of an array is percentile d sum. So this will give you the sum of elements of an array. Okay. I think it is clear to all of you. Okay. So similarly, you can try this. You just take the snapshot of this code and try this code. Definitely you will get the sum of elements of an array. Next, third is here, print the even elements in an array. Okay. So how to print even elements in an array? Okay. So I am just giving you the logic. You try to write down the code. This is example 3. Okay. So, or I have taken an array that is integer p, that is of size 7. Okay. So this is my array 1, 2, 3, 4, 5, 6, 7. This is 12, this is 9, this is 8, this is 15, 11, 7, 18. Okay. These are the elements of an array. How to check whether the element is even or not? So the code for this is 0, 1, 2, 3, 4, 5, 6. So you will take the for loop, that means for I equals to 0, I less than 7, then I plus plus. So while running this loop, we will check individual element. How we access individual element? This first element is accessed by a of 0. Second element by a of 1. So I'll check this by if a of I, okay, modulus 2 is equal to 0. That means if it is divided by 2 and this modulus operation gives me a remainder, that means a of 0 is how much? A of 0 is 12. If I am dividing this by 2, so quotient is 2, 6 are 12. This is 0. So this is my remainder. This is my quotient. So this modulus operation gives me a remainder. That means a of I 12, when I am dividing it by 2, if the remainder I am getting is a 0, then definitely this is an even number. Okay. So if I am getting an even number, okay, then what I will do, print the element. Okay. If this is 0, then printf %d / n a of I. Okay. If this condition satisfied, then only it will be printed, otherwise not. Okay. So this is how I'll be able to print the even elements in an array. Okay. So now let us discuss these. These are the operation on an array. Now let us go to some examples of your array. Okay. So coming to this question, here I have taken an array of size 5. I have initialized it to 1. Okay. So though I have taken the size of an array is 5, but I am initializing only one element into an array. So whenever I will print the array, that is printing the elements of an array, that means it will give you first element it is going to store as 1, the remaining element it will going to store as 0. Okay, because I have declared the array size as 5, but I am taking I am initializing only one element into that. Okay, so remaining element will be filled with 0. Coming to second question, choose the correct statement about C language. An array address is the address of first element of an array. Yes, because the array का address जो है, because मैंने बताया था आपको कि जब हम array लेते हैं ना, so this is my array. Okay, if this is array of 4, this is 0, 10, 20, 30, 40. This is 0th element, 1 element, second and third element. The base address of an array is stored in A. where A is the name of an array, if this address location is 1000, so this A will store 1000 and this will point to this location, or else A of 0 also gives you, address of A of 0 also gives you 1000. So this statement is correct. An array address is the address of first element of an array. This statement is correct. An array size must be declared if not initialized immediately. So definitely this is also true. That means while I am declaring an array and I am not initializing this, I must declare the size of an array. Okay. So array size is the sum of size of all elements of an array. Yes. Because if there are 4 elements in an array, the size of array will be 2. If this is occupying 2 bytes, is 2 plus 2 plus 2 plus 2. So total 4 into 2, that is 8 byte the size of array. Okay. So here all the above are correct. Okay. Then coming to 3. Chose the correct statement. Array size cannot change once it is created. Yes, it is true. That means if I am declaring the array size of 5 over here, this cannot be changed because already I declared the size of array 5. So if I am requiring more element, then it cannot be changed. Array element value can be changed any number of times. Yes. If my A of 0 equal to 12, so I can make it to A of 0 equal to 13, or I can make it to A of 0 plus plus. Okay, so I can change any number of times, so array elements can be changed. Okay, to access the nth element of an array, the index must be n minus 1. Yes, it is true. So it is all of the above. Okay. What is the output of this? So this is a character array and the characters are A, B, C. Okay. If I print grade of 2, so this is 0th element, this is 1 element, 2nd element. So this will give you, as the format specifier is percentile D, this will give you ASCII value of character C. So ASCII value is 67. Okay. So this is another question. Here I have declared a float of size 3, है ना? This is 0, 0 less than 3. This is always true. 0 less than 3 is true. So this will give you marks of 0. Marks of 0 is 90.5. Here I am incrementing A equal to 1. 1 less than 3 true. So this will give you second element, that is 92.5. Third element is 96.5. So this is my correct answer. Okay, see. Here also, here this is 0.2f. That means here I have to see what is the decimal. There must be 2 decimal point after percentile. Okay, so this is the correct answer, not this one. So this is 90.50, 92.50, 96.50, because it is declared 0.2f. That means after decimal point there must be 2 digit. Okay. So by this we end today's class. Thank you all. Have a good day. Bye bye.